you know, guys, scientists are rushing to find ways to reduce climate change. And by doing that, they are working on things such as carbon capture, reducing, carbon use, and many other things. And here in Iceland, we're next to the on-power plant, geothermal plant, and they actually try to work on, carbon capture. But how do they do this, actually? Well, we're going to be learning about that in this video. So here guys, we're in Iceland in the on-power geothermal plant, and they are the leading geothermal plant for carbon capture because they're using the CO2 and storing it into rocks underneath the earth so that, we can reduce climate change. And here we'll learn more about it with Mr. Kari.
Yes.
Yeah.
Hi. So, for the carbon capture and storage project that we have, it was first just developed to get rid of the emissions from the power plant itself. But then we saw that we could also take it out from the atmosphere in helping the world by reducing the carbon dioxide in the atmosphere. And it's a relatively simple way, as we can see from this over here, that we have the CO2 and we have the water, and then we simply put these two things together, and if you press this button over here, you can see that it goes underground, and there it will mineralize.
So when you press it, it becomes sort of like sparkling water here.
Exactly, yes.
And basically CO2 is just like carbon dioxide.
Exactly, yeah.
CO2, it's when carbon is mixed with oxygen.
Mm-hmm. Exactly, yeah. And the carbon dioxide, like you said, is of course used in, for example, soda. If you have a soda, you have carbon dioxide inside.
What is a soda?
Soda, for example, Coca-Cola. If you have a glass bottle of Coca-Cola, then you open it up, and then the bubbles that you get from the Coca-Cola.
And that is CO2.
Exactly, yeah.
Alright. And do you have any specific rock that you store the carbon dioxide into?
Exactly.
CO2?
Yes, exactly. It's called basalt. If you want to look at it, you can see it over there.
So now that we know that with CO2 and we try to put it into rock, we want to know more which rock we put it into, right? And here we can see, a large piece of basalt. All of this is basalt, right?
Mm-hmm.
And can you tell us why do we want to put the CO2 into this? Why particularly do we want to put this mixture of water and CO2, sparkling water, soda kind of mixture into basalt specifically?
Yes, exactly. So there are two things that you need to understand about basalt, and that is first that mostly basalt is very permeable. It has a lot of holes in it. So we inject the water into the ground, and then it fills up the porousness of the rock. But also, basalt has a lot of calcium in it, and it's a simple chemical equation that carbon dioxide mixed with calcite will form calcium carbonate minerals. As you can see, the white inclusions in these rock types. Yeah.
The white you can see in there.
Mm-hmm. Those are the calcium carbonates.
And is this good in any way? Is this better? What's the impact of this calcium?
Mm-hmm. The impact of this calcium is relatively no harm done, we can say, because this is a naturally occurring process. This takes nature just about maybe, let's say, 10,000 years to mineralize. Here we do it under such amount of pressure that we mineralize it in just the span of 2 years. Yeah. So we are imitating nature, so this is a relatively safe way of storing carbon in the ground.
Right. And when So as you say, it took 2 years. In those 2 years, how can you store it?
Exactly, yes. We, of course, re-inject it into the ground, and we do it at about 2 kilometer depth. So it's just stored underground. We don't want to store it above ground.
If there's an earthquake, it's just gonna...
Exactly, yes. It can open up and the CO2 can go back into the atmosphere.
And we don't want that.
No, we don't want that. So we do it at about 2 kilometer depth to have it relatively safely onto ground.
And like we saw, guys, basalt is a volcanic rock.
Yeah.
It's basically volcanic rock, basalt. And it's a very common one. So thank you. But can you tell us more about this red that we can see there? The brown red?
The brown red is what you call garnet, and that's just the way the basaltic rock forms. It's basalt has a lot of other mineral types in it. It's not only...
Well, that was unexpected. Spoiler alert, Dad is fine and ready for more filming.
Okay, as I was saying before my dad fell, so we were talking about these small red particles there. You can see small red paint there, we can see. And you were saying that this was some minerals which naturally form when they naturally go into the salt.
Exactly, yes. Garnet, and we also have some olivine inside of these cores, which are more green-like. And then amphibole, which would be some of the black ones, which we
yes, you can see one here.
Yeah, exactly. And these minerals just form naturally with the basaltic rock. And we have abundance of basaltic rock in Iceland. And so when we re-inject the CO2 into the ground, we just create the white mineral, which is calcium carbonate. Yeah.
Perfect. Thank you very much.
Thank you. Yeah. Thank you.